What is choke? How does it function and what is its application? Choke can refer to different things depending on the context: electronics, mechanical systems, or even in sports or daily life. Here's an explanation of its meaning in various fields. In electronics, a choke coil is a passive component that uses the principle of inductance to impede the flow of alternating current, AC, while allowing direct current, DC, or lower frequency signals to pass. It is essentially an inductor, a coil of wire typically wound around a magnetic core. Choke coils are primarily used in electrical circuits to filter out unwanted high-frequency noise and ensure smoother current flow. Key components. Coil. The primary part of a choke is a coil of wire, which creates inductance. Magnetic core. Some chokes have a core made of ferromagnetic material, iron, ferrite, etc., to increase inductance. However, air core chokes are also used when high frequency is involved to prevent core losses. How a choke coil functions. The functioning of a choke coil relies on inductance, a property of an electrical conductor by which a change in current induces a voltage, or electromotive force, that opposes the change in current. The faster the current changes, higher frequency, the greater the opposition from the choke. Low-frequency signals, including DC, when a low-frequency AC signal or DC current flows through the choke, it experiences minimal opposition because the magnetic field in the coil does not change rapidly. The current flows relatively unimpeded. High-frequency signals. High-frequency AC, on the other hand, faces significant opposition due to the rapidly changing magnetic field. The inductive reactance of the coil increases with the frequency, making it difficult for the high-frequency components to pass through. This selective filtering property makes choke coils useful for eliminating high-frequency noise or interference in electrical circuits. Types of choke coils. Power choke. Used in power supplies to smooth out ripples in DC voltage. It helps in filtering out high-frequency AC components from the DC supply. Radio frequency, RF, choke. Designed to block radio frequencies while passing lower frequency signals. RF chokes are used in radios, communication systems, and other circuits dealing with radio frequency. Audio choke. Used in audio equipment to filter out high-frequency noise while passing audio signals. Applications of choke coils. Power supplies. Choke coils are used in switching power supplies, like in computers, to filter out AC noise and provide stable DC output. Amplifiers. Chokes prevent the amplification of unwanted high-frequency signals by blocking them in audio and radio circuits. Communication systems. RF chokes filter out high-frequency interference, allowing clean transmission of desired signals in communication equipment. Signal filtering. Used in combination with capacitors to create low-pass filters that allow low-frequency signals to pass while blocking higher frequencies. Example of choke application. In a typical power supply, a choke is placed between the rectifier and the load to smooth out ripples in the rectified DC. The ripple is a residual AC component that the choke blocks, ensuring a more consistent DC output. Advantages. Effective filtering. Choke coils efficiently filter out high-frequency noise. Simplicity. They are simple, passive components that don't require external power. Durability. Chokes can handle high currents without significant wear or energy loss. Disadvantages. Size. Larger chokes, especially those with magnetic cores, can be bulky. Weight. The use of magnetic cores can add weight, which may be a consideration in some applications. Losses. In some cases, the magnetic core can introduce energy losses due to core saturation or hysteresis at high frequencies. In summary, choke coils are vital components in electronic circuits for controlling unwanted noise and ensuring smoother signal processing, particularly in power supplies, communication devices, and filtering systems. In mechanical systems, particularly internal combustion engines, a choke is a mechanism used to control the air-fuel mixture during the engine's startup phase, especially when it is cold. The choke is a part of the carburetor system, and its primary purpose is to restrict the amount of air entering the carburetor, allowing more fuel to enter the engine. This enriched fuel mixture makes it easier for the engine to start and run smoothly when cold. How the engine choke functions. Cold start condition. When an engine is cold, the fuel does not vaporize as easily, and a richer mixture, more fuel relative to air, is needed to ignite the engine. The choke helps achieve this by limiting the air supply. Choking the airflow. When the choke is engaged, it partially or fully closes the carburetor's air intake, reducing the amount of air entering the combustion chamber. With less air, the fuel mixture becomes richer, a higher ratio of fuel to air. Warming up. Once the engine has warmed up, fuel vaporizes more easily, and the choke is gradually opened to allow more air into the engine, restoring the normal air-fuel mixture for efficient operation. Types of engine chokes. Manual choke. In this system, the driver or operator manually operates a lever or pull knob to engage the choke when starting the engine. The choke can be gradually opened as the engine warms up. Common in older cars, motorcycles, and small engines like lawnmowers. Automatic choke. Automatic chokes use thermostatic control to automatically regulate the choke based on engine temperature. As the engine warms up, the choke automatically opens, reducing the fuel mixture. Found in many modern carbureted vehicles and small engines. Operation stages. Choke closed. When fully closed, the choke minimizes the air intake, making the mixture very rich. This is usually necessary for cold starting. Choke partially open. As the engine warms up, the choke opens partially, allowing more air to enter the engine, thus leaning out the air-fuel mixture. Choke fully open. When the engine reaches normal operating temperature, the choke is fully open, allowing an optimal air-fuel mixture for efficient combustion. Application of the engine choke. Carbureted engines. In older cars and motorcycles with carburetors, the choke is essential for starting the engine in cold weather. Small engines, lawnmowers, generators, and outboard motors often have manual chokes, which help the engine start when cold. Cold weather. Chokes are especially useful in colder climates, where engines need more fuel to overcome the difficulty in vaporizing gasoline in low temperatures. Modern replacements. In modern fuel-injected engines, chokes are largely obsolete. Fuel injection systems use electronic sensors and engine control units, ECUs, to automatically adjust the air-fuel mixture for optimal performance during cold starts and regular operation. These systems provide a more precise and efficient way to manage the engine's fuel mixture without the need for a choke. Advantages of the engine choke. Helps cold starts. A choke is crucial in starting an engine that operates on a carburetor, especially in cold temperatures. Simple mechanism. The design is simple and effective for controlling air-fuel mixtures without needing complex electronics. Disadvantages. Fuel inefficiency. When the choke is on, the engine consumes more fuel, reducing fuel efficiency. Manual operation. In manual choke systems, the operator has to remember to disengage the choke once the engine warms up, or else the engine will run rich, which can lead to poor performance, fouled spark plugs, and wasted fuel. Example of operation in a lawnmower. In a lawnmower equipped with a manual choke, when the engine is cold, the operator pulls the choke lever to engage it. This enriches the air-fuel mixture by limiting airflow. After starting the engine, the operator gradually opens the choke as the engine warms up to allow more air in and optimize fuel combustion. In sports, particularly in martial arts and combat sports, a choke hold is a grappling technique used to control or incapacitate an opponent by restricting their airflow or blood flow. Choke holds can either limit the oxygen supply to the lungs by constricting the airway, air choke, or cut off the blood flow to the brain by compressing the carotid arteries, blood choke, potentially leading to unconsciousness if applied for too long. Types of choke holds. Air choke. An air choke works by applying pressure to the windpipe, trachea, obstructing the airway and making it difficult or impossible for the opponent to breathe. This type of choke hold primarily targets the respiratory system. Risks. Air chokes can be painful and dangerous if not released promptly, as they can cause damage to the windpipe or result in asphyxiation. Example. The guillotine choke, where an opponent's neck is trapped under the attacker's arm, compressing the windpipe and restricting airflow. Blood choke. A blood choke compresses the carotid arteries on either side of the neck, limiting the flow of blood, and thus oxygen, to the brain. This type of choke is usually less painful but more effective, as it can quickly lead to unconsciousness if held for a few seconds. Safer. In skilled hands, blood chokes are often considered safer than air chokes in controlled environments because they work more efficiently and typically don't cause physical injury, provided they are released promptly. Example. The rear naked choke, RNC, where the attacker's arm encircles the opponent's neck, applying pressure to the carotid arteries to cut off blood flow to the brain. Function of a choke hold. Submission. Choke holds are primarily used in submission grappling and mixed martial arts, MMA, to force an opponent to tap out, submit, conceding defeat in a controlled match. The opponent taps the mat or the attacker to signal they cannot escape or continue without risking injury. Incapacitation. If a choke hold is held for too long, it can cause the opponent to pass out due to a lack of oxygen to the brain. In competitions, referees carefully monitor choke holds to prevent harm, and in self-defense situations, they are used to neutralize threats quickly. Control. Choke holds can also be used to control an opponent's movement without necessarily applying full force. They can be employed to position or pin down an opponent during grappling exchanges. Common choke holds in sports. Rear naked choke, RNC. One of the most common and effective blood chokes in Brazilian Jiu-Jitsu, BJJ, MMA, and submission wrestling. The attacker gets behind the opponent, wraps one arm around the opponent's neck, and locks the choke by clasping the other arm behind the opponent's head. This technique cuts off blood flow to the brain by compressing the carotid arteries, often resulting in unconsciousness if not released. Guillotine choke. An air choke often used when an opponent tries to shoot in for a takedown. The attacker traps the opponent's head under their arm and applies pressure to the throat, compressing the trachea and restricting airflow. Triangle choke. A blood choke applied using the legs, commonly seen in Brazilian Jiu-Jitsu and MMA. The attacker wraps their legs around the opponent's neck and arm, using one leg to compress the carotid arteries, restricting blood flow to the brain. Arm triangle choke. Similar to the triangle choke, but applied with the arms instead of the legs. The opponent's own arm is trapped alongside their neck, and pressure is applied by the attacker's arm and body. Ezekiel choke. A choke often seen in Brazilian Jiu-Jitsu that can be performed from a dominant position like mount or back control. The attacker uses the sleeve of their GI uniform to apply pressure to the opponent's neck. Application of choke holds. Brazilian Jiu-Jitsu, BJJ choke holds are a core technique in BJJ, which is a grappling-based martial art. Practitioners often use chokes to control or submit opponents. Mixed martial arts, MMA chokes are frequently used in MMA competitions because they are effective and allow fighters to submit their opponents without striking. Judo. Judo also incorporates choke holds, known as shimewaza, which are often applied in groundwork, nawaza, to force an opponent to submit. Safety and regulations. Controlled release. In competition, choke holds are regulated, and referees closely monitor fighters to ensure they do not hold the choke too long after an opponent taps out or loses consciousness. Tapping out. Fighters are encouraged to tap out before they pass out or suffer injury. Tapping is the universal signal in martial arts to indicate submission or surrender. Banned in some sports. In sports like amateur wrestling or judo at certain levels, choke holds may be banned or restricted due to safety concerns. Advantages of choke holds. Effective submissions. Choke holds are highly effective and can end a match quickly, often without causing serious injury when applied correctly. Non-violent control. Chokes can neutralize an opponent without resorting to strikes, which can cause long-term damage. Self-defense. Choke holds can be useful in real-life self-defense scenarios where the goal is to incapacitate an aggressor swiftly and escape. Disadvantages of choke holds. Risk of injury. If applied incorrectly or held too long, choke holds can cause serious injury, including damage to the trachea or carotid arteries, or even lead to death by asphyxiation. Requires skill. Successfully applying a choke hold, especially in a combat sport, requires proper training, positioning, and timing to avoid injury or being countered. Illegal in some settings. Certain choke holds may be prohibited in specific competitions or self-defense situations due to their potential danger. In summary, choke holds are powerful grappling techniques used to submit, control, or incapacitate opponents in combat sports. While highly effective, they require proper training and caution to ensure safety during application. In common language, choking under pressure refers to the inability to perform at an expected level in high-pressure situations, often due to stress, anxiety, or overwhelming emotions. It happens when someone who is typically skilled or competent suddenly fails or underperforms when stakes are high. This can occur in sports, public speaking, exams, decision-making, or any situation where there is a strong external pressure to succeed. How choking under pressure occurs. Increased anxiety. When faced with a critical moment, such as a final in sports or an important presentation, a person may become overly anxious about the outcome. This heightened anxiety interferes with their ability to concentrate or recall skills they usually execute easily. Overthinking. In stressful situations, people tend to overanalyze or second-guess their actions. Instead of performing instinctively or relying on muscle memory, they may try to consciously control every move, which can disrupt the flow of performance. Self-doubt. Pressure can lead to self-doubt, where the individual begins to question their own abilities. This mental distraction makes it harder to focus and perform at their best. Fear of failure. The fear of failure, especially in situations with high expectations or significant consequences, can paralyze a person. The more they focus on avoiding failure, the more likely they are to choke. Psychological mechanisms behind choking. Cognitive overload. When pressure increases, the brain can become overwhelmed by trying to process too much information at once. This cognitive overload prevents clear thinking and hinders the ability to execute tasks that are usually automatic. Performance anxiety. When individuals worry excessively about the outcome of a performance, their attention shifts from the task itself to the consequences of failure, reducing their ability to perform effectively. Loss of focus. Distractions caused by external pressure can divert focus from the task at hand. For instance, an athlete might start thinking about the crowd, media attention, or the impact of losing, rather than focusing on the game. Examples of choking under pressure. Sports. Athletes may choke during high-stakes moments such as championship games, penalty kicks, or final seconds of a match. For instance, a basketball player who usually makes free throws may miss crucial shots when the game is on the line. Public speaking. A person who is normally comfortable speaking in front of others might freeze or stumble over their words when faced with a large audience or a critical presentation. Exams. Students who perform well in practice or lower-stakes tests may blank out or make simple mistakes during high-pressure exams like finals or standardized tests. Business or leadership. In high-pressure decision-making environments, such as negotiations or crisis situations, a leader may make poor or irrational decisions that they wouldn't typically make under less stressful circumstances. Why people choke. High stakes. The perceived importance of a situation increases the pressure, leading to stress and the potential for choking. Expectations. When people feel that others, coaches, teammates, colleagues, or even themselves have high expectations of their performance, the fear of letting them down can cause choking. Overemphasis on outcome. Focusing too much on the end result, winning, success, not failing, can create mental blockages. Instead of concentrating on the process, the individual becomes fixated on the consequence of failure. How to avoid choking under pressure. Focus on the process, not the outcome. Staying present and focusing on the steps or techniques required to perform well can help reduce anxiety over the result. Practice under pressure. Rehearsing or simulating high-pressure situations can train the mind to stay calm when it matters most. Athletes, for instance, may practice with crowd noise or simulate game-winning moments to get used to pressure. Relaxation techniques. Breathing exercises, meditation, and mindfulness can help reduce stress and prevent overthinking. Learning to relax before and during a high-pressure situation can improve performance. Positive self-talk. Replacing negative thoughts like, "What if I fail?" with positive affirmations such as, "I've practiced for this," can help maintain confidence. Routine. Developing a pre-performance routine can help focus the mind and reduce the impact of pressure. Athletes often use rituals like bouncing a ball a certain number of times before serving or taking deep breaths before a race to stay grounded. Examples of famous choking moments. Sports. In 2004, professional golfer Phil Mickelson was infamous for choking in major golf tournaments until he won his first major at the Masters, after years of near misses. Public speaking. Politicians or public figures may choke during televised debates or speeches when they stumble over key points or forget their lines due to the pressure of a live audience. Exams. A student who consistently scores high on practice tests may choke during a final exam, unable to recall information they knew well due to test anxiety. The opposite of choking. Clutch performance. While choking refers to failure under pressure, the opposite is known as a clutch performance, where an individual rises to the occasion and performs exceptionally well in a high-stakes situation. Clutch players are often admired for their ability to stay calm and execute their skills in moments of extreme pressure, like basketball player Michael Jordan, consistently making game-winning shots. Summary: choking under pressure is a common phenomenon in high-stakes situations, where stress and anxiety disrupt a person's ability to perform at their best. Understanding the psychology behind choking, practicing stress management techniques, and focusing on the process can help mitigate its effects, allowing individuals to perform more consistently even in pressure-filled environments. Each of these chokes serves a specific purpose, whether in filtering signals, improving engine performance, controlling opponents, or describing human behavior.